सो कह रहा है कि इन द बोर मॉडल ऑफ द एटम विच ऑफ द फॉलोइंग ऑप्शंस आर करेक्ट. ठीक है, तो रेडियस ऑफ द nth ऑर्बिट क्या होता है इज इक्वल टू 0.53 इंटू एन स्क्वायर बाई जेड. राइट, इट्स इन एंगस्ट्रम. सो आर एन is directly proportional to n square, so 1 is correct. Total energy of the nth orbit, तो En क्या होता है हमारे, En is equal to minus 13.6 into z square by n square. Right, so En is directly proportional to 1 by n square, is inversely proportional to n, not is inversely proportional to n square, so this is wrong. Right, the angular momentum of the electron in an orbit is an integral multiple of h by 2. so जैसे कि हम जानते हैं from Bohr's second postulate, है ना, क्या जानते हैं हम कि हमारे पास एंगुलर मोमेंटम ऑफ एन इलेक्ट्रॉन इन मूविंग इन एन ऑर्बिट इज एन इंटीग्रल मल्टीपल ऑफ एन एच बाई 2 पाई, दैट इज mvr शुड बी इक्वल टू एन एच बाई 2 पाई फॉर एन इलेक्ट्रॉन टू स्टे ऑन द ऑर्बिट. दिस कंडीशन मस्ट सेटिस्फाई. राइट, सो द एंगुलर मोमेंटम ऑफ द इलेक्ट्रॉन इन एन ऑर्बिट इज एन इंटीग्रल मल्टीपल h बाई 2 पाई. दिस इज ऑल्सो करेक्ट. एंड अब हमसे पूछ रहे थे मैग्नीट्यूड ऑफ द p ऑफ द इलेक्ट्रॉन इन ऑर्बिट इज ग्रेटर देन इट्स k. राइट, तो इस इक्वेशन से हमारे पास ये तो है सेकंड पोस्टुलेट के हिसाब से. राइट, और फर्स्ट पोस्टुलेट हमें क्या बताती है, फर्स्ट पोस्टुलेट इज सो फर्स्ट पोस्टुलेट के हिसाब से, है ना, क्या है हमारा कि जो सेंट्रीपिटल फोर्स है दैट इज mv स्क्वायर बाई r शुड बी इक्वल टू द दिस द इलेक्ट्रोस्टैटिक फोर्स. राइट, सो इट इज इक्वल टू k ze स्क्वायर बाई r स्क्वायर. राइट, सो हमारा mv स्क्वायर की वैल्यू क्या हुआ, k ze स्क्वायर बाई r. ठीक है, तो काइनेटिक एनर्जी के ई क्या होता है हमारा, हाफ एम वी स्क्वायर. सो इट इज इक्वल टू हाफ के जेड ई स्क्वायर बाई आर, है ना. अब इलेक्ट्रोस्टैटिक पोटेंशियल एनर्जी क्या होता है, इलेक्ट्रोस्टैटिक पोटेंशियल एनर्जी इज इक्वल टू माइनस के जेड ई स्क्वायर बाई आर. राइट, अब मैग्नीट्यूड देखेंगे, मैग्नीट्यूड ऑफ पी इज इक्वल टू के जेड ई स्क्वायर बाई आर विच इज ग्रेटर देन के जेड ई स्क्वायर बाई 2r, है ना. सो विच इज इक्वल टू के. राइट, so magnitude of p is greater than in an orbit is greater than its k. The 4 is also correct. So हमारा option B is correct, right? Because 1, 3 and 4 are correct, है ना. So option 2 is सही. ठीक है.
Hello, we are given with a question and the question says consider a hydrogen-like ionized atom with atomic number with a single electron. In the emission spectrum of this atom, the photon emitted in 2 to 1 transition has energy 74.8 higher than the photon emitted in 3 to 2 transition. The ionization energy of hydrogen atom is 13.6. The value of Z is what? So first of all, delta E has a formula that is equal to 13.6 Z square into 1 by NF square by 1 by NI square. This is the formula. So in case of delta E 2 to 1, that is equal to 13.6 Z square into 1 by final state is 1. So it is 1 square minus 1 by 2 square. So this value turns out to be equal to 13.6 Z square 1 minus 1 by 4. So that is 3 by 4 here. Similarly, delta E for 3 to 2 transition. So that would be equal to 13.6 Z square into 1 by 2 square minus 1 by 3 square. So that turns out to be equal to 13.6 Z square. So it would be 1 by 4 minus 1 by 9. So 1 by 4 minus 1 by 9, which is equal to 13.6 Z square into 5 by 36. So from here, since we are given in the question that delta E 2 to 1 is delta 74.8 more than the energy in transition 3 to 2, right? So what we can say is that from here 13.6 Z square into 3 by 4 would be equal to 13.6 Z square 5 by 36 plus 74.8 it is. When we rearrange this, so this term comes over this side, so it is 13.6 Z square into 3 by 4 minus 5 by 36 equals 74.8. So Z square turns out to be equal to 74.8 divided by 13.6 into this value. So it would be 3 into 9, that is 27 minus 5. So it is 36 by 22. So when we calculate this, z square turns out to be equal to 9. So z cannot be negative, z would turn out to be plus or minus 3, but z cannot be equal to minus 3. Therefore, our answer is z equals to 3. So our answer is z is 3 here. That is our answer. Thank you.
Hello students, our question is the recoil speed of hydrogen atom after it emits a photon is going from n equals to 5 state to n equals to 1 state is dash meter per second. So solution for this will be, we know that momentum of H atom, momentum from conservation of linear momentum of H atom will be equals to momentum of photon, which means mv is equals to del E divided by C. So del E, if we calculate del E, it is equals to E5 minus E1. Okay, so minus 13.6 into Z, which is 1, into 1 upon 5 square minus 1 upon 1 square electron volt. So on solving, 13.056 into 1.6 into 10 raised to the power minus 19 in joules. So we will get 2.09 into 10 raised to the power minus 18 joules. Okay, this will be our del E. Now it is given that hydrogen, so mass of hydrogen is 1.67 into 10 raised to the power minus 27 kg. So if we put all the values in this equation, so we will get answer. So V will be equals to del E divided by MC. So now putting all the values, so V will be equals to del E is 2.09 into 10 raised to the power minus 18 divided by M is 1.67 into 10 raised to the power minus 27 and C is 3 into 10 raised to the power 8. So on solving, we will get the value of V equals to 4.17 meter per second, and this is our answer. Thank you.
Hello friends, question is given here. In the Bohr model of hydrogen atom, the ratio of kinetic energy to the total energy of electron in a quantum state n is. Okay, so in the nth quantum state, the relationship between total energy and kinetic energy here in nth quantum state, relationship between total energy and kinetic energy and potential energy is equal to total energy is equal to kinetic energy plus potential energy. Okay, but potential energy is equal to minus of 2 times of kinetic energy. Okay, so hence expression for total energy, hence we can write the expression for total energy is equal to how much? Total energy is equal to kinetic energy plus potential energy is minus of the 2 times of kinetic energy. Okay, so from here total energy is equal to kinetic energy and minus 2 times of kinetic energy is equal to, this will be how much? Minus of the kinetic energy. Okay, so hence the ratio of kinetic energy, ratio of kinetic energy to total energy, kinetic energy to total energy is equal to how much? Here kinetic energy upon total energy is equal to how much? -1. Okay. So ratio will be, this will be not in negative. Okay. This will be integer ratio. So total energy, kinetic energy upon total energy ratio will be how much? 1. Okay. So see here option second, here this option second plus 1 is the correct option. Thank you.